default, we can start our chain with yarn chain. Nice, and in a new terminal window, we're gonna deploy our contracts for the first time with yarn deploy. Now we can check the interface with yarn start. And we can open up localhost with control plus click. Yes. Yes, it's here. It's too low, my voice? Okay. Thank you. Okay, so we can inspect the interface with the fresh deployed contracts, but right now it's not going to show anything. It's going to show just the outline of what we're building, right? We're building this DEX contract, which is going to have a balance of ETH and a balance of balloons, which is our ERC20 token. This is the address for the DEX contract, and here we're going to have two functions to swap the tokens, right? We're going to be able to swap the native token, in this case ETH, to balloons, and we can swap balloons to ETH as well. We're going to do a way so that other users can deposit some tokens to the DEX contract, and they can earn liquidity pool tokens, liquidity provided tokens, and some withdraw function to allow them to take these tokens back. And this is our balloons contract, which is an ERC, like ERC20, like we all know, and it has all the methods from the Open Zeppelin's ERC20 standard. Right, we don't see anything on this right side because here's gonna display here's gonna be displayed a curve on the token balances so that we can see how how when we deposit or withdraw tokens or swap tokens, it changes the token curve. And this token curve is gonna have the token reserve and the ETH reserve displayed here. Okay, so moving on to checkpoint 1. Well, as I said, we have the balloons contract. Of course, we can inspect that one in your editor of choice. I'm gonna open up my VS Code. Let me just close this one down. Yep. And in the packages hard hat contracts folder, we're gonna find the balloons contract and the DEX contract. Balloons contract is gonna be the ERC20, and the DEX is gonna inherit all functionality from the ERC20 from Open Zeppelin, and the DEX contract is gonna be our main contract where we're gonna work today. As you can see, the DEX contract has some comments inside. It has all the methods that we're gonna build. It has an init function, a price function, get liquidity, ETH to token, token to ETH, deposit, and withdraw. These are all the methods that we're going to work on today. And it has already some events that we can use, like, for example, the basic ones. When we swap ETH for balloons, we're going to emit this event. When we swap balloons for ETH, we're going to emit this one, and so on and so on. Right? It also has already a constructor where we have an instance of our token. We have done this before as well. This is just we bring up the interface and we send the balloons contract address. And in this way we can call the balloons contract methods and get some results, or write some results to the contract. We're going to use this one so that we can get or transfer balloons to or from the contract or from a user or to a user. Okay, so let me continue. Yes. So, firstly, the guide tells us to add some variables to the contract, to the DEX contract. This is going to be a total liquidity variable and a liquidity one. The total liquidity is going to show the total amount of ETH that we're going to have in the contract, in the DEX contract, and the liquidity is going to show how much tokens each user has in our DEX. So we can do that by, we have some questions here. If you're following the guide, which I did not send, let me send it here. If you're following the guide, you're going to have some questions here that are going to help us build the contracts and finish the challenge. But we also have like the solution straight away here. And I'm gonna try to copy these ones and just explain it bit by bit so that we can finish on time. Because you know it's gonna take forever. Okay, so our first two variables are already here. We can just copy them. I'm gonna paste it here as well. Add this. Okay, so we're gonna add them to our DEX contract. Be over here. Oh, I forgot to mention that the contract also has some guides on where to put the variables, where to put events and public functions. So it has some comments here that you can say. Following the standards and good practices. So we're going to follow a good practice and put the global variables up here. Okay. So what's this? This is going to just be an integer, right? And this is going to be a mapping from user addresses to how much to an integer, right? How much liquidity they have. Let's continue. And for our DEX to work, we're going to need it to have some tokens in the some balance in the contract, right? And when we deploy the contract, it's going to have 0 ETH balance and 0 balloons balance. So we're going to have to create a function called init, in which we are going to send some tokens and some ETH to the contract so that we can start swapping right away. So the init function is here. I'm going to copy, paste it here as well. And we're going to replace this one here. Okay, so this is going to be a public function, and it's going to be a payable one as well, because we need to send some ether when we call this init function, and thus we're going to add we're going to have to add this payable keyword. And this is going to return how much liquidity we added, so it's going to return integer. But first, we gotta make sure that we don't initialize the contract twice or after it's already initialized. And that's why we have a require here. If the total liquidity in the contract is 0, we're gonna revert the transaction saying that the contract is already has some liquidity, so we don't need to add more. And here we're gonna grab the total liquidity by using the address function, passing the this keyword, and getting the balance. Right, this is gonna return the balance of the contract, the amount of it that the contract holds. And this is going to add the total liquidity to the message sender because he's the first one who's sending all the liquidity to the contract, and thus he's going to have all the total liquidity in the map to his address, right, in the liquidity mapping. Then we're going to have a require as well, and this require is going to check for the transfer to be successful. If this transfer from the user, which is transferring balloons from his wallet to the contract, to the DEX contract, if this transfer is not successful, it's going to revert the transaction. So we are making sure that the user sends it and that the user sends balloons. Remember that here we are using the balloons contract and we're calling the transfer from function from the balloon contract, which is over here, if you remember, right? This transfer from is going to take who is the sender, in this case the message.sender, to where it's, we're going to transfer the balloons, and this is going to be the address of the DEX contract, which is address this, and how much balloons we're going to transfer to this contract, right? And then we just return the total liquidity. Fairly easy. So we can already redeploy this contract and test that one out. We can go to our debug contracts tab and just find the DEX contract and the init function. Just got to be here. Yeah, now remember that when we use the debug contracts tab, we are using way. So here, if we put 1, it's not 1 it, but 1 way. And we can convert this over here. Oh yeah, remember to grab some funds from the faucet here, so that your wallet has some funds to send transactions. I'm going to first check if my wallet address has some balloons, which is the ERC20 token, right? And we can check this one here. We copy the address and we just call the balance of. Now I have 0 balloons, so I gotta mint some for myself first, and I guess this is the I should have some balloon balance, because otherwise I will not be able to provide the DEX contract with balloons. So I'm gonna check what I missed here and just come back to you in a bit. You guys have here 10 balloons. You guys have something different than 0 here, or you also have 0? If you're following the guy. Paul? You have 0 as well? Okay. Yeah, okay, I understand what's going on. So since we are not deploying from this wallet address, but from a wallet from the local chain, it's using one of these accounts to deploy the balloons contract, and this is the account that's getting the balloons balance. Bless you. So we can check that one out here as well. If you grab, I think it's the first address. Let me see. If we grab the first address from the local chain, we can see if he's the one that owns all the, yes. So he's the one that owns all the tokens. Right? We still haven't transferred any tokens to my front-end address. I guess we're going to do that later, but for now, we can see that we have the init function here on the DEX contract over here. And okay, so first we're gonna transfer some balloons to my front-end address, and I guess we have this step here as well. It says go to deploy your contracts.ts and uncomment this section. I'm gonna paste this here as well. You can navigate with Control P, deploy contracts.ts, deploy contracts.ts, and here you're gonna have the commented section. It's gonna be here. So we're gonna uncomment this, and we're gonna grab our front-end address here, right? Copy address and then just paste it one here. Okay, so now my front-end address is going to have some balloons, and I'm going to be able to see that. Let's just redeploy the contracts using the reset keyword so that we get new contracts. You have the 10 balloons? Nice. So you can see the 10 balloons here, and you can also check from the debug contracts tab with in the balloons contract. You can check it like using the balance of. I can copy my address and just send a check here, and it should be 10. Yeah, so we have 10 balloons right now. Okay, let's move on. And we already did this. Nice. So if we try the init function now from the DEX contract, let's try. Since we already have some balloons and some ETH in our wallet in this address, we can already initialize the DEX contract with some balloons and some ETH. We can do this by calling the init function. I'm gonna go with let's say I'm gonna go with 0.1 ETH. 0.1 ETH. You can use this unit converter I already sent. 1 ETH, and it's going to be this amount of weight. So I'm going to try with this amount of weight and tokens as well. So since I have 10 balloons, and balloons also has 18 decimals, I can use this one for balloons as well. So I'm gonna try to initialize the contract with 1 balloon, let's say. So it's going to be this amount of weight. Okay, so this is interesting, right? We got an error because if you remember, we cannot just use the another contract to get some tokens from my wallet. I first gotta approve this other contract with the approve function, so that he can use my tokens to transfer. We already learned this on previous lessons, so basically we're gonna use the approve function that's on the balloons contract and allow our DEX contract to get some balloons from my wallet, from the user wallet.
Can you repeat the last step, the init, please?
Yes. Do you have the balloons balance here?
Yeah.
Okay, nice. So I'm just sending the init function with I'm using this unit converter so that I send 0.1 ETH, which is this amount of weight. I'm getting this amount of weight, copying and pasting here in the payable value weight. Yes. And here is the amount of balloons that I want to send. So I just since balloons also use 18 decimals like Ether, I can use the same unit converter. And if I wanted to send the whole balloon balance that I have, I would send 10. But I just want to send 5 or 6. Let's say 6. So 6 balloons is going to be this amount of weight balloons, let's say. So I can just paste this here, and I can see. I guess I have already sent some balloons. I don't know if this is going to work, but. Yeah, but it says insufficient allowance, which is what I was explaining, right? The DEX contract doesn't have permission to get some balloon tokens from our address, from our account. So we first gotta approve the DEX contract.
You are putting in each the if, that there's writing tokens is there is or if in each we have to send if.
Where? Sorry.
Within each we have to send the tokens of balloons or if.
The first parameter is balloons.
Mm-hmm.
But the balloons use the same amount of decimals.
The payable value.
Yeah, the payable value is.
Yeah. This is ETH and this is balloons. Yes.
But there you have to calculate
With the unit converter.
Oh yeah.
Yeah, I'm using the unit converter.
Yeah, but you do the price.
Sorry?
You do the price that one ETH is 6 balloons.
Yes, we're going to talk a bit about that because currently, if we are the first ones deploying this or depositing these two tokens, the native token and the balloons token to the DEX contract, it's going to set the price for that. So that, let's say 1 Ether is going to, 6 balloons is going to be worth 1 Ether, right? So we have the power to set the price here because we are the only ones that are providing these tokens to the DEX contract. And this is how DEXs work. But I'm going to explain this in a bit later. Just there's some explanations that I gotta use as well. Over here it explains how the price works. Okay. Yes, so we were on the approve step, right? We first got to approve the DEX contract to use our balance of balloons, right? We can do this one from, not here, from the interface itself here in the DEX tab. We can just call the approve function here. We can take the DEX contract address, copy, paste, and how much balloons tokens I want the DEX to be able to withdraw from my wallet or my account. In this case, I have 10 balloons, so I guess I can just send like 6 balloons, so that the DEX can only take up to 6 balloons from my account. Okay, so it says transaction completed successfully, and if we go back to our debug contracts, we can try the init function again, and this time it should work if I send this amount of balloons, let's say 1/8. Okay, so I need a little bit more ETH. Yes. Nice. Okay, so transaction completed successfully, and we can check this one here in the DEX interface. We can check that the DEX contract already holds 1 ETH and 6 balloons. Okay, and we can already see the balances reflected here on the curve. I will explain more about this in a bit. It failed?
Was saying that I don't have the loads seen to
How much ETH do you have? Okay, so it's good. How much? Did you approve the DEX contract?
Yeah.
Here? Okay. Oh, okay. Let me see. See where it's it. But this is not the address of the DEX contract. It's this one here.
Yeah.
Yes.
to approve. I have to approve the DEX contract.
To use my balloons on from my account. Yes.
Interact. Okay.
Otherwise, I would have to send directly from my account to the DEX contracts on balloons. So yes. In this case, we are calling the transfer method from inside the DEX contract. So we gotta approve the DEX contract to use this function and get some balloons. Nice.
Thank you.
Nice.
No tengo 20 porque no tengo ¿cuál es ese paso? Me perdí ahí.
No, aquí ya tienes. Ya. Y de ahí hay que mandarle a este contrato con la función init. En la función init le mandas.
En el debug.
Ajá. Uy, tienes hartísimo.
No se lleva ese, pero ¿cuál, dónde?
Init. Ahí está. Ahí le mandas.
¿Cuánto? ¿0.1?
O sea, si quieres 0.1, si quieres le mandas 1. No. Esto es en. Chévere, tienes.
No, es que aquí le aplastas y se convierte
Sí,
automáticamente.
Richísimo.
Ya. ¿Cómo que le pongo 0.1?
Ya, sí, ponle. No, esto es balloons.
Entonces, ¿qué le toca?
Si tienes 10 balloons, mándale lo que quieras.
Pero no
8.
tengo. Sí.
Verdad.
¿Qué me perdí?
Ya, hay una aquí en el Deploy Contracts. Ya la tienes. Solo tienes que volver a desplegar los contratos.
Y te da 10.
Deberías tener 10 balloons, pero con reset.
Reset.
Sí, porque no has cambiado el contrato.
¿Debería actualizarse?
Debería, déjame ver.
O hice algo mal.
Aquí, entonces la dirección está mal. Cópiale ese. Cópiale. Vuelve a. Aquí sí, no lo has cambiado aquí. Sí. Yo tampoco me había dado cuenta. No has guardado.
Ya no había entendido ese paso.
Sí.
Y ese dan 10. Se supone, ¿no?
Se supone, a ver. Chévere.
Ya,
Ahora sí, anote al ¿cómo se llama?
¿Al init?
Al primero approve, porque tienes que aprobar al DEX.
¿Qué?
No, ahí mismo donde estabas.
Uy, ¿qué pasó?
No se sale esa vaina.
Ok. ¿Dónde?
Ajá, ahí. Ya estás ahí. Abajo.
have.
Ahí tienes approve. Mándale, cópiale, perdón, me olvidé. Cópiale la dirección del
Yes.
DEX. Ajá. Sí está, ¿no?
Y de ahí, el 100.
Sí, ¿cuánto quieres? ¿Cuántos
5,
cuántos balones?
Oh.
Pero 5 por... Déjame. Ah, sí, creo que solo 5 nomás. Ajá, a ver, dale. Ah, tú estás usando MetaMask, chévere.
Toilets. Ahí sí que yo te pregunto después, muy bueno.
Ya, dale, está bien. Okay, so we have done all this, right? Now our DEX can interact with our balloons and just grab some balloons from my account. And now, we did all this. Now it says like, let's just avoid using this approve from here and initializing the contracts manually, and just use the deploy script to do these steps. So we have this. We can do this automatically just by uncommenting these lines of code in the deploy your scripts. So here, we just uncomment this. And we can see that here, it's calling the approve function. Oh, let me just plug in this. It's calling the approve function for the DEX to use the balloons contract, and it's calling the init function from the DEX by sending 5 balloons. I'm sorry. 5 ether to the DEX. So we're gonna see that in action right now. We're gonna run the yarn deploy command again with the reset flag. So let's go. I'm gonna put some instructions here on comment lines 57. And yeah, let's check our interface. Oops. Did it work? I'm not sure.
For me, there's an error, but I think that is because I don't have enough beef, maybe. And I had to start again the chain. I think it will work.
Okay, try. You should have like enough it because it's 10,000.
Worked.
It worked? Nice.
Yeah, you're right.
Okay. Do you have 0 and 0 as well here?
No.
No, I have 5.
Okay, maybe I did not. Yes, I did not save the script, so I'm gonna just try again.
I mean, the only yarn deploy, not yarn deploy reset. I think that is because.
No, it was because I hadn't saved the file. I forgot to save it. So now I just save it and run it again. And right now it's displaying the 5 ETH and 5 balloons as balance. Right? It's already initialized. If we try to initialize again, it will fail. So I don't know what this is. I have no idea, but let's just try the 1 ETH and 1 balloon. Yeah, DEX already initialized. It already has liquidity, so it won't allow us. Nice. Let's just continue and yeah, checkpoint 3. Oh, here there's a little catch, like if you are planning to submit this challenge, we should just add a get liquidity function getter here in the dex.sol. So go to the dex.sol and here you're gonna have get liquidity function, and this is just a simple getter for the liquidity variable. It already suggests me this, so I'm gonna use this one. This is getting the liquidity mapping here and just returning with the address that I want to inspect, right? How much liquidity this address LP has. Fairly easy. We don't need to test that one out. So now is the hard part. If you have never checked how a DEX works or how an automated market maker works, this is like the math behind it. Like you have seen that we have ETH balance and a balloons balance, right? So in this case, this is the math formula behind DEXs, and in this case, my ETH will be X, let's say, and my balloons will be Y, and K is a constant. When I first deposit some ETH and balloons, I get like a constant value, right? And this should hold true for whatever swaps I do after. This formula should be true with whichever movement I do to the swap. This is going to be a constant, and this is going to maintain the balance of ETH and balloons like stable, let's say. So when a user comes to the DEX and wants to buy some balloons, he's going to have to deposit ETH. And since he's going to have to deposit ETH, let me just draw this one because I cannot do it without some graphics. There are some very cool videos about this that might be better for the people that learn graphically. And I'm gonna send those ones after in the Discord. But for now, just look at the DEX like I don't know the name of this. You know the name of this? For the weight balances. Like you put a weight in here and you put a weight in here. What's the name of the?
Scale.
Scale, right? Thank you. So just look at the DEX like a scale, right? The DEX is going to have some balance of, let's say, ETH, right? This is going to be ETH, and this is going to be balloons in our case, right? Balloons. And it's going to try to maintain equilibrium, let's say. For now, we are having like 5 ETH, 1, 2, 3, 4, 5, and 5 balloons, 2, 3, 4, 5 balloons, right? If a user wants to get 1 balloon from the DEX and he has ETH, he's going to have to deposit some ETH, and he's going to get some balloons in exchange, right? Some balloons, let's say. And this is going to be like, this is going to increase the balance of ETH to be 6, and decrease the balance of balloons to be 4. So on the next swap that another user do, the token with the less liquidity is going to be the, I don't know how to explain this. The price is going to be different for the next balloon that the user swaps, right? Because we already have some more ETH and less balloons. That means that the balloons are going to be worth more ETH, right? And this is just, how do I say this? Just the basic principle of demand and, what's the other word? Supply and demand, yes. Yes, so this is how it works. And the mathematic formula is this one, x times y is k, right? And we're going to have to calculate how much balloons and how much ETH the user gets when he interacts with the DEX contract, right? And this is going to be using this formula as well. I'm going to try to explain this one as quickly as possible so that we don't go too far. Well, here you have a nice article about this. I'm going to send this one here as well. So if you're more interested on these formulas, on the math behind DEXs, you can check this one here. It has how Uniswap works, Uniswap v2, which is what we're using right now, just this basic formula. And it also has some nuances of Uniswap v3, which is a little bit more complicated on the maths, but it adds more features for the users, right? But the basic principle is this. Just there's a formula, and the formula maintains the prices, or let's say, yeah, the price of the tokens, or the other token, one or the others. Let's see, here it talks about trading fees. Normally, when we use a DEX, there's like a small trading fee that the DEX takes from the transaction. So every swap is going to take like 0.3% of the amount that the user deposits, and it's going to store that inside the contract. So we're going to have to take that one into account as well. And to calculate the price of one or the other tokens, we're going to use this formula here, which is going to be X in our case is ETH, and Y in our case is balloons. So if we're trying to get some balloons for ETH, the user is going to have to deposit some more ETH, right? And we're going to grab some balloons from the DEX contract. That's why it's a subtraction. And here's an addition, right, for ETH. So we're going to have an additional ETH and a subtraction of balloons, and we're going to get the price of balloons, or we're going to get this amount of balloons from the DEX contract. So this is the calculation that's going to take place here in this price function. So we're going to use this price function to get the amount of tokens that we're going to get on a swap or an exchange. Okay, so navigate to your DEX contract, right? And here you have price function over here, and we're going to replace this one for this. Okay, so here's calculating how much the user is inputting, or yes, how much is the X, but subtracting the 0.3% fee that the DEX takes. That's why it multiplies by 997. And then it's calculating the numerator and the denominator here according to this formula that I showed you, right? Numerator, denominator. And it's adding the input, which would be this one. And then it's going to return just the amount of tokens, numerator, denominator. Okay. It's not that simple, but I recommend you study it a bit more, like reading in parallel with checking the contract, so that you understand. It's very easy when you check it like a little more detailed. So, okay, we have the price function. We can check the price function if we run yarn deploy. Okay, let's go yarn deploy. Work, we can see the book contract index, and then we have the price, right? Yes. So let's say we want to get like we want to get some balloons in exchange of 5 ether, or let's just say 1 ether. How much balloons will I get if I enter 1 ether, and the contract has 5 ether and 5 balloons? It says that I will get 0.83 balloons, right? And this is taking into account that the DEX has taken the fee, the percentage from this amount, and it's going to return 0.83 balloons. That's the output of the formula, and it makes sense because if we always had like a 1:1 ratio of exchange, then the price curve will not hold. This invariant will not hold. The curve that you have here, and the principle and the basic principle of the AMM is that this maintains a constant, right? So that's why we don't get 1 balloon from this output, but 0.83. And here it talks a little more about slippage as well. If you care about it, you should read it, of course. But I'm not going to dive into it right now because it's a little more complicated. Yes, so basically what I showed you right now, it calculates the price based on this formula over here. So it does some tests, and you can try this ones as well, but I'm not going to do that now. Did I paste the price here? Yes, it says you should be able to go through the price section, this section, and test with these numbers as well. But let's move on to the trading section, because this one is also very important in the DEX, right? For now, we just have like a way of checking how many tokens I would get if I swap, but we don't have that interaction here. So if we try anything here, it's not going to work. It's just going to show me what I would get if I swap, like, you see that reflected in the curve? But it's not, if I send it, it's not going to work, right? So let's just do that implementation. And we're going to start with the ETH to token function. This is going to be for when a user sends some ETH to the DEX contract and gets some balloons in exchange. So you have some guiding questions here. But these guiding questions are already answered in the solution, right? So we're going to grab the solution from here. So we're going to navigate to our DEX contract and just add the ETH to token function here. So first, we're going to require that the user actually sends some ETH. So this is the step. We compare that the value is greater than 0, basically. And then we're gonna grab the reserve. Here's an interesting catch that it doesn't show in the guide. I saw this message.value here, that it's subtracting from the balance of the contract. And I said, oh, okay, that's interesting. Why it subtracts message.value and it does not only just get the balance from the contract? And it's because when you send a transaction or you send some ETH to the contract, this is the first thing that gets executed before all the logic in the function. So if we're gonna get the balance of the contract, the real balance of the contract, to calculate this, we gotta subtract the value that the user just sent to get the real balance. I don't know if this was clear, but basically yes, because this is the amount that we need to use to calculate the tokens that we're gonna receive, the balloons that we're gonna receive in exchange of this ETH. So this is why it subtracts the message.value here.
Yeah.
Nice. So then we're gonna get the token reserve, and this is gonna be fairly easy. Just we call balance off from the token contract, and just get the token reserve. I'm trying to do this a little bit quick because we are already 7 past 11. So I guess I'll try to cover the next step and just leave everything for a homework. Okay, so here we got the ETH reserves and the token reserves, and with these two, we can already calculate the price of the balloons, right? And we do this by calling the price function over here. Yes. So we send the amount of ETH that the user is sending, we send the reserves of ETH that this contract has, and we are sending the amount of balloons that this contract has. And this is going to calculate the amount of the balloons that we're going to send back to the user in exchange of his ETH, right? Yes. So here's the step where we actually send the balloons to the user, and we require that it's successful. If not, we revert the transaction, and we emit the ETH to token event, right? And this is just for front ends, I guess. We return the token output. Okay? I think it's clear.
Yeah. We have to get the token to ETH, no?
Yes, and now we gotta do the token to ETH, which is basically the same but the other way around, and you're gonna notice that one right away. So here we have the token to ETH function. I'm just gonna copy and paste it here as well. Okay, so you have it. As you can see, the signature is quite different already, because here we don't need argument. We're just saying some ETH in the message.sender variable, right? Message.value, sorry. But here, and we gotta do that payable as well. But here, since we are not sending ETH, we gotta receive some tokens, right? And this is why we need the argument of token input. And this function is not payable because here we do not need to send some ETH. And this is as well when I return the ETH amount that the user is going to get. And the steps are the same. We require that the user sends some tokens, some balloons. We grab the token reserve, so the balloon reserve, with the same method over here, right? Same method. And we calculate the amount of ETH that the user is going to get with the price function that we already coded. We're going to send the token input, which is here. We're going to send the token reserve, which is here, and then just get the balance of ETH that the contract has, which is the ETH reserve. Right? And then we're going to require that this transfer was successful here. The transfer of tokens from the user to the DEX contract. And we're also going to require that the transfer of ETH from the DEX contract to the user is successful. And we're doing that here. So if both transfers are successful, we just emit the event and then return. I hope that it's clear. Kind of similar to this one. So I guess we can try those two right now. We're gonna run the yarn deploy command and just see if they work. Okay, so I have 30 tokens in my wallet. I have 5 ETH in the DEX contract and 5 balloons. I'm gonna try to swap 0. Let's say just 1 ETH. How much balloons I'm gonna get? I can already see that here. It says 1 ETH input is gonna get me 0.83 balloons. So let's try that one out and see. Ooh, I guess I don't have enough balance, so I'm gonna grab some funds. Okay, and let's try again. Nice. So you can see that the balance of ETH in the DEX contract increased by 1, and then the balance of balloons in the DEX contract decreased by 0.83. Nice. Yes, very nice. So we can test this one again, and as you can see, the next swap is not going to return me 0.83 balloons again, because we already have different balances of ETH and balloons in the DEX contract. And because of the formula that I showed you, the next time that the user wants to swap ETH to balloons, he's going to receive less balloons, because basically there's more ETH in the DEX contract and less balloons, and so the balloons cost more, right? So this is how a DEX works. Of course, this is an example. We have very little token amounts here, and we're trying with big swaps like 1 ETH. If we try with a very little amount like 0.01 ETH, you can take note of this output 0.0069, and we're gonna see if it's similar to a next swap that we do. Let's try a next swap of 0.001. And you can see it's already very similar amounts, right? Because we are dealing with lower amounts, the price does not change that much. So, yeah, all thanks to the formula of the DEXs. We can also try a swap from balloons to ETH, and I have 30 balloons, 30.83. I'm gonna try to swap, let's say, 3 balloons. And it's already telling me that if I input 3 balloons, I will get 2.5 ETH in exchange. I'm going to try that one now. Okay. It says I have not enough allowance. So since I previously allowed the DEX contract to use my balloons, it has already used all my balloons, so I need to run the allow approve function again, right? I'm gonna try to approve the DEX again with 3 balloons, approve 3 balloons, and send. And now the transaction should work because now the DEX has access to my balloons, right? So I got my balance of balloon decreased by 3, and I got my balance of ETH increased by, I can't remember the value, but it has increased. So everything is working, the deposit and the withdraw function. Again, I'm not gonna take that much time in this because we're already over time. So let's do this one very quickly. So some of you might wonder why we gotta add a deposit function if we already have liquidity or tokens in the DEX contract. Why do we need a deposit function, right? But this is how DEXs work, or Yes, like swaps, like Uniswap, SushiSwap, all these protocols, they allow everyone to deposit tokens. Because it would be unfair if just one person is the one that controls all the tokens balances in the DEX contract. So they have this deposit function for everyone to use. That's why it's public and it's payable. And this is going to allow a user to transfer some balloons and ETH. For any user that wants to deposit tokens to the DEX contract, they're going to have to deposit ETH and balloons at the same ratio that the first deposit happened. And how is that checked here? It uses the ETH reserve, like we use it above. It uses the token reserve, and it's calculating how much of tokens he should deposit according to the amount of ETH that he's sending. Right? I don't know if this is clear or if you have any question here.
I have, but I'll ask after.
Okay, yes. Yeah, this is kind of complicated stuff, and it's kind of complicated for me to explain as well. Okay, so it's gonna calculate how many balloons to deposit based on the amount of it that the user is sending, and using the reserves as well to calculate the price. I'm not gonna explain this because I don't know about this last one, but there's like a discussion here that they are linking, so you can check that one out after. And I guess here is extracting the amount of liquidity minted, and then adding this to the total liquidity in the contract, and as well to the liquidity that the user has in the mapping. Remember that we had a mapping above, so here's updating the mapping. And so it requires that the token transfer is successful, and of course here we already require that the user sends the ETH, so we are checking for the ETH and the balloons balance to be sent, and we are making the event of the liquidity provider. So now any user can deposit some tokens to our DEX contract. And now we're going to do the same thing, but to allow users to withdraw the tokens from the DEX contract. This is here, so we're going to just start from here. Okay. So very similar to the deposit, the withdraw function also checks for that the liquidity of the sender in the contract is greater than the amount he wants to withdraw, because he cannot withdraw more than what is in the contract, right? And he's getting the ETH reserves, getting the token reserves, and then it's calculating how much ETH is going to be withdrawn depending on the token amount or ETH amount, right? And here is doing the sending, right, with the call function, and it's withdrawing this amount of ETH, and here is transferring this amount of balloons. So it's doing both, right? Transferring ETH from the DEX contract to the user and transferring balloons from the DEX contract to the users. And now it's emitting just the liquidity removed event and returning the value withdrawn. Okay. Also here I have like a little warning that says this is the same name as up here, so it shouldn't show this variable, but we don't care about that now. I guess we can just redeploy the contracts and test. Okay.
You can paste in document. You can paste the
Oh, the what? Sorry?
withdrawal.
The withdrawal.
The withdrawal.
Yes. Right. We can try some swaps like 0.1 ETH and send the transactions, right? We can try some balloon exchange as well. Just like, let's say I want 0.8 balloons, and I can get that amount of ETH. But yes, we should allow DEX contract to spend some balloons from us. Paste the DEX address here, just right, approve the sender. Let's say I want him to spend 3 balloons, so I just send this, and now I can just swap some balloons. So everything is working right, and now I'm gonna try to withdraw. I don't know how much. Let's see. Let's say I want to withdraw, I don't know how much I already have in there, but I'm going to try to withdraw 0.1 ETH and see if it's successful. No, so I don't have enough liquidity, so I'm going to just try a lower amount, let's say 0.01. No, not enough. So I gotta provide some more. Let's say I would provide just 1 ETH. Oh yeah, I haven't done any deposits, right? And this is why my balances in the DEX contract have not updated. I first gotta deposit some ETH here. So I'll just try to deposit 0.1 ETH. That's right. Okay, it's successful. You can see that the DEX contract balance updates. And now I can withdraw my 0.1 ETH or less. Let's say I want to withdraw 0.9 ETH, 0.09. And it's working. So every balance here updates, everything on the curve updates, the prices updates, all according to the formula, the reserves of ETH and the reserves of balloons that we have in the DEX contract. Okay.
Very strange.
You had an error?
I'm trying to deposit 0.1 ETH and see that I don't have enough ETH, but I have like 1.
I will check with you just a minute. I gotta finish the Yes, so yeah, there are some steps here. You can edit just the front end with more functionality and meet the proof of event function. And yes, there's some more side quests that it says here, not necessary, but you can do them. And then the next steps are like always, to deploy your contracts to a testnet and then just ship your front end with Cursor so that you can submit the challenge. This we have already done before, so you can do that on your own. And yes, if you have any questions about this, you can always ask me. I'm on the DeFi side of the ecosystem, so I know pretty much about DEXs. I'm also doing a DEX, so I know how this price curve works, and you can just ask me after. So I guess, thank you.